This is feedback for the component 3 mock, and it was paper 3 of that. Question 1. We've stuck a locust in a tube, and it's connected to the outside air via another smaller tube, and we're looking at visible breathing movement. So this is to do with gas exchange and looking at experimental results and interpreting them. So there's quite a lot of higher order thinking in this, AO3 sorts of skills and applying what you already know. So this locust, you can see the movements of the thorax, abdomen, in and out, and that's how the locust moves the air in and out of the spiracles, down the trachea and so on. And that's how it does gas exchange. And why did the student leave a locust in the boiling tube for 5 minutes before she began the first count? You might be tempted to say equilibrate here, but that's really for things to get up to the right temperature, or that sort of thing. Here, with it being a living organism, it needs time to get used to the environment it's put in. It might be shocked or stressed to start with. Just until it gets used to it, it might increase its rate of movements. So this is acclimatization, or getting used to the environment. So getting used to the environment. And the posh word for that is acclimatization. Here, describe and suggest explanations for the effect of breathing out into the boiling tube. So the experimenter breathed into this tube, and their expelled breath and filled this tube. We've got a description of the data in the table. So this is AO2, where you are describing data and then applying it to your knowledge. And we've got the starting breaths per minute, then we've got a dramatic increase, and then doesn't seem to increase very much. If you were drawing this as a graph, it's always a good idea to, in your mind, draw a graph. You've got the number of times on the bottom, 1, 2, 3, 4, number of breaths, 10, 20, 30, 40, 50, 60, that sort of thing. And we start off at 16, so roughly there, then it goes up to 59, 61, 58, 60. So you see this rapidly goes up and then doesn't seem to increase. And you can do that on a rough sketch like that. So we are describing the effect of breathing out. So we can say that one breath causes a dramatic increase in the breathing movements, and that'll certainly get us one of our marks there. So one breath causes an increase in, what word should we, body breathing movements. We'll just copy that from there, then there can't be any confusion. The mark scheme says pumping, so if you copy that out of the mark scheme, well, it doesn't mention pumping here, and it isn't kind of pump, so I wouldn't say that. Increase in body breathing movements. And then we can describe this part saying, well, further breaths don't increase the breathing movements any further. So further breaths have little further effect, or the rate of breathing movements stays steady. Words to that effect. And now, well, we've got 4 marks here, so 2 marks for a description is probably enough. And then let's go on to the explanation. Well, possibly 1 breath. You imagine it's not a very big tube if you've seen the size of these locusts. So if you breathe out into here, you'll probably fill the tube with your breath. And so if you then breathe again, well, that's just filling it again with the same stuff, and breathing again, filling it again with the same stuff. So probably 1 breath will fill the tube as much as you need to. So 1 breath filled the boiling tube. Yeah. Further breaths have no further effect on the atmosphere, the content of the atmosphere there. And explanation, right, well, we could go for low oxygen as a cause, a higher CO2. We're not quite sure, and we're not expected to know, but it's a sensible suggestion, KA3. So, the increase in rate is due to low oxygen or high CO2. In humans, it would be the high CO2 that would affect the rate more, but we don't know in the locust. And we can suggest, we've got our 4 marks now, but we can suggest why it kind of levels off. So we've explained this part of the curve. Well, shall we try and explain that? Maybe the locust has reached its maximum rate of breathing. It can't breathe any higher, no matter how much you fill the tube. So possibly locust has reached the maximum breathing rate. And indeed, it's always worth trying. Sometimes you can blag a description mark by including some of the data. So, for example, saying that there's an increase from 16 to 59, so an increase of 43 breathing movements, and that will blag you a mark there. And part B suggests 2 factors other than change in CO2. So we can't mention that. You'd be surprised at how many people do, which may have affected the rate of breathing movements. So this could be thinking about controlled variables, really. What other things would you try and keep the same? So you're only investigating your independent variable, which is breathing. So, for example, an obvious one that quite often is going to be useful is temperature. And we don't need to suggest which way it would go. It's just a factor. And if we've said carbon dioxide concentration, well, maybe the oxygen concentration would affect this, so I'm going to suggest that. O2 concentration, or the partial pressure of O2, sometimes called that. And other things you could possibly suggest. We only need 2, but things like humidity, or something to do with the animal itself. If it's stressed for any particular reason, if it sees you poking around near the tube, it might think you're going to eat it, and it might increase its breathing movements. So stress, fear, that sort of thing. Or if it just decides to move around, gets hungry and goes for a wander, that might affect its breathing movements. So activity of the locus there. So those are generally considered to be kind of controlled variables that you want to keep the same in an experiment. 7 marks.